So geometric probability obviously has geometry in it. And so if we just had a rectangle, it's the little bit harder than a square. And I said it was 2 by 8. You would remember that has an area of 16. It's like 16 little squares. So if I actually like tried to make them into little squares, of course areas they can be circles, they can be 1, 2, 3, 4, 5, 6, 7. Let's just go like this. There, now it's got 16 little squares. Now, if I were to let my gerbil run around in a cage that has this on the floor, and he just stopped at some random moment and I took a picture of him, what's the probability he'd be on this square or this square? Assuming all the squares are equal size, what's the probability that the gerbil would be on one of those two squares? Well, what's the area of the whole thing? 16. What are the areas of each little box? Well, they're each 1 by 1, you know, like, so they're each 1. So this is 1 and this is 1. So what is area in general? It's what you want over all the things that were possible. That's what I told you from the beginning about probability. It always comes down to the things you want over the possible things. And how many are there of the things that I want? There's 2. Out of how many total? 16. So that's 1 in 8. And what's that probability? Well, I'd have to actually divide it. Now, I happen to have 1/8 memorized. Anybody else have that one memorized? Very good. 0.125. So that is a probability, a 12% probability that the gerbil was going to be on those 2 spots. Now, of course, this assumes randomness. If I had put like food on one of the spots, that would increase the probability he's going to be there a lot. And if I put a snake on one of the spots, then it's going to decrease the chances to be there. So this assumes randomness. All right. That essentially is what we're doing today, and it is so easy. If you can just find areas. So let's talk about what do you need to know to be able to find areas? You got to know these 3 basic shapes. Would you just find the area of these 3, but take out a calculator? I would use a physical calculator just because then you don't have to split screen, which is kind of like split your brain in half on your calculator. You're always going back and forth. If you've got a physical calculator, I'd use it. If you don't, all these are going to be is dividing, so you can use the iPad if you want to. I just think it'd be better if you've got a calculator to use that. Now, let's be careful with the units because you are in Algebra 2. So instead of just saying the answer for the first one, which is 49, say more than 49. Hopefully you know how to say the units right. Maybe you forgot this about geometry, but it's kind of a big deal. How to do units. Now, the fact that we're doing probability means that you're always going to be dividing one by another one. So even if you screwed up the units, they would cancel anyways. It is not 49 feet. Do you remember what you're actually supposed to put? Square feet, yep. So this is FT, and you can have a little square like that, or you can write SQFT, square feet, because they really are little squares, okay? Because if I actually divided this up into little squares, and I actually made it have 7 spots, 1, 2, 3, 4, 5, 6, yep, there we go. And I do that in the other direction, they'd be little squares. All right. How about the circular one? Did you remember? I'm curious, be honest. I'm just looking for honesty here. How many of you remembered the formula was pi r squared? I'm just curious. That is most of you, but not all of you. You'd have to know that on the test or you'd been toast. No way to get this area without that formula. So what is pi? Well, it's about 3.14. I'd be fine if you use that. If you also want to use the actual pi button, that works. Who remembers the fraction that's kind of close to pi? Say it if you know it. 22/7. Cam, fountain of knowledge this morning. All right. So you don't have to use 22/7. It's not exactly pi. Like if you go way back in history, they thought it was 22/7 because it was so close. But now we know it's not. It's just really close to that. And then r squared, well, r is 3, so 3 squared is 9. So it'd be 9 times 22/7. Or 9 times, if you use the pi button, it's probably the fastest to get a calculator, right? All right, so then, Sid, what'd you actually get when you typed that in? 28.27. And I hear you, we got to stop the decimal at some point. That's a pretty logical place. Now, is that a probability? No, it's just a circle. What if I had a circle inside the circle? And then I said, what's the probability if I dropped a penny from up above and it landed in there? What's the probability it would land right there? Like, you could do something really complicated with this, with like the penny and actually dropping it 1,000 times. And then you have to define, does the penny have to stay inside the circle, or does it just have to be like partway in the circle, or does it have to be halfway in the circle? You could make this really complicated, but if I just want to keep it simple and say that has a radius of 1 and the whole thing has a radius of 3, you can't just do 1/3. That would not work. You'd have to do the area of the little circle and then put it over our other answer we already had. So what is it? Pi r squared. So what is it? It's pi times 1 squared, which is just really pi. So it's really 3.14. You get what I did there? I found the area of the little circle, which was pi r squared, but r was 1, so then it was really just pi. And then I divide it by the 28.27. What is 3.14 divided by 28.27?
3.14 divided by 28.27 is approximately
0.1111. All right. Now that's about 11% chance. Okay, are you with me so far? All right, I want to take just a second since that number came up, which is 0.1 repeating. Do you remember what 0.1 repeating is as a fraction? 0.1 repeating. All right, this is one you should have in your little like bag of tricks. 0.1 repeating is 1/9. Memorize that one. I'd also memorize 1/8. Comes up a lot. 0.125. It's good to know that one. Everybody knows that 1/4 is 0.25. Like there's some that everybody knows. 1/2 is 0.5. Everybody knows that. But the ones that come up more like occasionally, but it's handy to know, 1/8 and like 1/9. But because if you know 1/9, then you know 2/9. What is 2/9 going to be then? 0.2 repeating. 0.2222222 goes on forever, never repeats. And this brings up the 0.3 repeating, which is 3/9, which is the same as 1/3, and 0.6 repeating, which is 6/9. Catching on to the pattern, it's always 9ths. If it repeats the same number over and over, it's 9ths. Okay? But then this is the one that breaks people's brains. 0.7 repeating is 7/9. 0.8 repeating is 8/9. And 0.9 repeating, people feel like, oh, but that one's different. That one's an exception. Well, it's not. It's 9/9. And the reason that this bothers people so much is they think, well, it's just a little tiny bit less than 1, but it's actually 1. It's actually equal to 1. And we talked about it briefly. Today is a day where this lesson is so easy. I want to just expound on this a little bit more. Repeating decimals can be written as fractions. It's just one of those things about math. If it is a repeating decimal, then you can write it as a fraction. So this has to be able to be written as a fraction. So if it's not this fraction, what is it? And it also makes sense. 8/9 was 0.8 repeating. 9/9 is going to be 0.9 repeating. All right. And for those of you that are more of a little math nerd, if you have a little bit of math nerd in you, I want to show you this proof, which is what my teacher showed me way back. For the first time I saw this was in college. And so I want to expose it to you a little bit earlier. He said this is just a mathematical proof that unless you can find something wrong with the proof, then it must be true. You just say n is 0.9 repeating. You can set n to be anything you want. So I'm going to say n is 0.9 repeating. So take a second. I'd like you to write this down. It's just an equation. And tell me if you see anything wrong with what I do. Would you agree I can do anything to both sides of the equation that I want to? I could add something to both sides. I could subtract something from both sides. I could multiply by something on both sides. All right, so I'm going to times by 10 on both sides. Of course you can do that. You know that. So write what you have when you get done. You have n equals 0.9, and you times by 10 on both sides. And what do you have? You have 10n. And then what do you have on the other side? Do you know the rule about multiplying by 10? What do you do with the decimal? Times by 10, don't you just move the decimal over one spot? All right. So this would be 9.9 repeating. Okay. Next thing, remember, I can add anything I want. I can subtract anything I want. I'm going to subtract n from both sides. But n is 0.9 repeating. They are the exact same thing. So I'm going to just subtract 0.9 repeating from this side and n from that side, because they are the same thing. I defined it at the beginning that n was 0.9 repeating. So if I subtract n from both sides, like I just did, then that's legal. What's 10n minus 1n? And again, sadly, some of you think it's 10. No, it's not 10. What's 10n minus 1n? 9n. And what's 9.9 repeating minus the 0.9 repeating? 9. And then if you just take a second and solve it, n equals 1. Divide both sides by 9. So if I guarantee you, you can go home to your really smart mom or dad, the one who's, maybe sometimes both of them, are really good at math, and tell them a 0.9 repeating is equal to 1. And you will get an argument. They'll be like, no, it's not. It's really close, but it's not 1. And then this is, I've shown you 3 different ways. The most powerful, easiest one is to say, because you can Google this, or AI it, and just say, can repeating fractions be written, repeating decimals be written as a fraction? And then the answer is yes, they all can. So then show them the 0.7 is 7 ninths, 0.8 is 8 ninths, 0.9 is or 0.9 repeating is got to be 9 ninths. Or you can show this proof if they're really math nerds. They'll appreciate knowing that 0.9 repeating isn't just close to 1. It is 1. It's exactly 1. Blew my mind the first time I saw that. Okay. All right. Go to page that has this little bullet. No, it's not a bullet. It's a target, but it's somewhere over here. Dartboard. There we go. Okay. So you're trying to hit the middle, and you've all seen a dartboard. Probably most of you have probably thrown darts. You know, it's pretty hard to hit that middle spot, even if you're aiming for it. And now this is an important part. If you're actually aiming for it, this is a bad problem, because do you get probability assumes randomness? And if you're actually aiming for the middle, aren't you going to hit the middle more likely than if you just randomly threw it on the page? Okay, so I want to tell you that this would not be a good problem because it's not random. But if we give you a problem like this on the test, you should still do it. You can't just say, oh, it's not random, so it doesn't count. I mean, even though I'm bringing that up, it's a good point. We still can. They just should have changed the problem to, instead of throwing darts and assuming you're aiming at it, they could have had you like blindfolded, or they could have made it windy so you really weren't going to be able to hit the middle anyways, or like something to randomize it. All right. So in the end, what do you want? You want the middle. Then you'll figure out the area of the middle and what's possible, the whole thing. So if you always come back to what you want over what's possible, take a second, figure it out. Of course, they're both circles. Of course, they use pi r squared. Use calculator. Get your decimal answer. See, that 0.9 repeating equals 1 thing is, one of those things that you usually math teachers are like, got too much to do. I can't take time to show that. But I have determined it's worth the few minutes because a lot of times those are the things kids remember more than the rest of the stuff. It's good math. All right. So if you did pi r squared on the top, pi times r is 0.5 squared. Make sure that you don't screw up your order of operations. I would get the decimal answer on the top before I went and just divided. Uh-oh. Yes?
Since it's the diameter, wouldn't it be?
Oh, the diameter is 0.5 inches. Very nice. I guarantee you a lot of kids didn't catch that. I didn't catch it. I just assumed it was telling me the radius, but you can't assume. All right, so if the diameter is 0.5, that means all the way across. Then the radius would be half of that, so 0.25. Very good. I won't make that mistake next hour. All right, and then pi r squared on the bottom, and the radius in this case is not 15. It'd be, diameter is 15, so it'd be half of that, so 7.5 squared. Now, one thing, if you want to save some time, do you get that these pi's would cancel? You get that? It's part of a times problem, so then you can cancel it. So then that really means 0.25 squared over 7.5 squared. What is 0.25 squared? 0.0625. What is 7.5 squared? 56.25. What is 0.0625 divided by 56.25? 0.001111. I'm going to pause for a second. Did you guys get the same thing? Yes? Be honest. I could have, the calculator could have screwed up. Did you get the same thing? Raise your hand if you were positive you got the same thing as me. All right, that's most of it. Good. All right. Look at that. Is that a 10% chance of hitting it? Is that even a 1% chance of hitting it? No. Now, why do you hit it more than 1% of the time? Because you're aiming for it, and that changes the probability. But if you just randomly threw it, didn't care where it hit, weren't aiming at anything, somehow randomize it, you'd have only a not 1%. It'd be 1/10 of 1% chance of hitting it. Okay. Cool. Moving on. I saw this question once, so I'm going to be honest. I did not make it up myself, but I changed the numbers to make it nice and easy to work out. I thought that's a good real world situation. Now, bad part, if goats actually like to eat dandelions, then it totally changes the probability. Or if goats don't like dandelions, like maybe they taste kind of bitter or something, then that changes it too. But assuming it's completely random, then now I got to figure out not just the area of a circle, you got to do a lot more math. It's actually pretty complicated. Can you just take this area of the circle and subtract off the area of the square? No, because the square goes outside the circle. So what we want on this one is super easy. 5 times 3 is 15. The area we want is 15. Super easy. Out of, what's possible? Because the goat can't go in the barn. All right, this one, it's going to take a little breakthrough for some of you to try to figure out, like, how can we figure out the area of the circle that we have left? I'm going to give you this hint. Isn't it a percentage of the circle? It's not half the circle. All right, take a second. You're going to get an answer, and you're going to put it here. And then you're going to divide the two and get a decimal. Point something. And then please share that with the kid next to you. I'm going to pause for a second. This is the first time I've asked you to talk to the kid next to you. And if they're like, I have no idea, then help them figure out what percent of the circle it is that he could possibly be walking around in. Okay, so if you took the approach of saying it's a percent of the circle. I gave you a big hint on that one because I didn't want people to just be completely stuck. So it would be, well, judging by that's a 90-degree angle out of a total of 360 degrees, then do you get that you have 3/4 of the circle left? 3/4 of the pi r squared. And our radius in this case was 10 feet. So 10 squared is 100. And then I could do 3/4 of 100 would be 75. And then last thing I'm gonna do is multiply by pi. And so that's gonna be, I do not know what 75 times pi is. What is 75 times 3.14? What is 15 divided by 235.5? Raise your hand if you got 0.0636-ish. Okay. All right. Now, if you didn't, I totally understand. This was a tricky question. You might have tried to do, I'm going to take the area of the circle and subtract the area of the barn, but that doesn't work because the barn sticks out beyond the circle there. See? So you can't just take the area of the circle and subtract off the barn. That would not work. You got to figure out what percent of the circle you had. All right. We're just going to do this one. Oh, question?
Does it matter, like, if you use, like, the actual, like, button of pi or 3.14?
Excellent question. You get that 3.14 is a shortened version of pi and therefore not as accurate. Mm-hmm. Okay, so on a test, I would allow you to use 3.14. But the pi button is more accurate. And will it matter? Probably only in like the tenths, like the hundredths or the thousandths place. So it could make a difference on a test. And if you in a future class where the teacher has not guaranteed you that I will take the answer with 3.14, then I would use the pi button for sure because it's more accurate, and it could be off for in the like 4th place or something. Yes. I guarantee you that on the test we have used 3 decimal places. Period. So might as well just get used to it that way. So if it doesn't say, use 3 decimal places because that's what we're going to be doing on the test. All right. So last one, and then you are going to be launched into your homework, which you are going to probably finish in class. Nice, easy day back. So let's do this one together. And I'd like you to figure out that in the big picture, it's what you want over what's possible. But it's not as simple as I'm going to take all the circles and divide by the square. It's not necessarily that. Sometimes the bottom is easy to figure out. Sometimes the top's easy to figure out. How are you going to get the area of these weird little diamond shapes? Don't think of it that way. How are you going to get the yellow area? Talk to the kid next to you about how are you going to get the yellow shaded area. All right. I've done a lot of these, so learn from just my experience. It's not perfect, but this is just a little sketch out idea. You just go, okay, if I knew the area of the square and I subtracted all of the areas of the circles, so you can go like, if I took the square and I subtracted, and then I got to figure out how many circles. 1, 2, 3, 4 by 1, 2, 3, 4 is 16 of the circles, then I'd have it. See, in the area of the square, then I can go back and figure out what that is. It's 4 by 4 is 16 square feet. Now, if they really wanted to mess with me, they would have told me the length of the radius of the circle in inches, and that would have been a classic trap. One of your answers is in feet and the other's in inches. That's going to screw it all up. You have to stay consistent. Now, in this case, each of these was 1 foot because it's 4 feet, right? And there's 4 of them. So, but that's not the radius. So you be careful and you don't go, oh, I'm going to change it from 1 foot to 6 inches. You see how that would mess you? You messed yourself up if you did that. Because you can't mix inches and feet. So the area of the square is 16 feet. Minus 16 of the circles. The circles you have to use a half a foot for your radius. All right. And then it's all divided by the possible, which was the whole thing, which was 16. So it's 16 minus the 16 circles. All right, so I'm going to get my final answer and see if it's the same as yours. What is 0.5 squared? What is 0.25 times pi? What is that times 16? All right. I think you can see that you can't cancel these 16s. Why? Because this is part of a subtract problem. And if you did cancel those 16s, you'd think the answer was 12.5, which would be no probability. There's no probability that goes above 1. So you obviously can see you can't cancel those 16s. What is 16 minus 12.5663?
16 minus 12.
What is that divided by 16? 0.2146. Anybody get the same thing as I did? All right. I'm not surprised that I don't have too many hands because this is a tricky question. But 21% chance that you're going to land in the yellow. All right. I think you got the idea. I'm not going to even do this last one. I think you'd have the idea. You'd take what you want over what's possible, which is add up all of these different shapes and put that on top. And what's possible is super easy. 20 times 10 is 200. But adding up all those things on the top would just be the long part. All right, so you get to your homework, which looks like this. It's a Schoology quiz. It's only like 5 questions. And I'm on purpose giving you a nice, easy back-in homework. There is a worksheet I could have assigned, but it's way longer, and I didn't want your first day to be painful. I know it's hard to get back in the swing of things. Nice, easy Schoology quiz. Okay, now, some pro tips. If you are one of those 5 or so kids that need to take the test, if I were you, I would switch gears and I would actually start studying for that in class because I'm here and you can get some help from me for the next half hour. If you don't come up and ask me a question, if you haven't taken the probability part A test, if you don't come ask a question this hour, you're missing a chance. Why not get the help of the teacher during this half hour? Because I probably won't have too many questions. So, all right, that's all I got for you for today.